Hello everyone. Now let's continue on this section 4.3, the multiplication rules for probability. So we only have two parts. One is we're going to talk about multiplication rules, and then continue on that. We're going to talk about conditional probability. So the multiplication rules. So two events, A and B, are independent events if the fact that A occurs does not affect the probability of B occurring. So when the outcome or occurrence of the first event affect the outcome of the occurrence of the second event in such a way that the probabilities change, the events are said to be dependent events. So for two events, we either say they're independent or they're dependent. So when two events are independent, the probability of those occurring is going to be probability of A equals probability of A times probability of B. Probability of A and B going to be probability of A times probability of B when they're independent. If they're dependent, then the probability of both occurring going to be probability of A and B equals probability of A times probability of B given A. So this term is the conditional probability. So now let's look at that. The conditional probability of an event B in a relationship to an event A was defined as the probability that event B occurs after event A has already occurred. The notation for conditional probability is probability of B given A. So this little bar here, it's a line actually. We call it given, rated as given. Probability of B given A. Then we have the following formula for this conditional probability. So probability of B given A equals probability of A and B divided by probability of A. Why? Because when we look at the multiplication rule, so probability of A and B equals probability of A times probability of B given A. So if we want to know this conditional probability, we're just going to move probability of A to the left side, and then we're going to divide it by probability of A, and then the right side is going to cancel out. So it's a extension of the multiplication rule. Then now let's look at an example. The probability that Sam parks in a no parking zone and gets a parking ticket is 0.06. The probability that Sam cannot find a legal parking space and has to park in the no parking zone is 0.2. On Tuesday, Sam arrives at school and has to park in the no parking zone. Find the probability that he will get a parking ticket. So basically, we're gonna rewrite all the sentences into the stat notation. So the first one, we're gonna look at the events. So we say let A be the event that Sam parks in a no parking zone. And let B be the event that Sam gets a parking ticket. So we use these two capital letters to represent two events. Then let's see what we can translate for that whole paragraph. So what we know the probability that Sam parks in no parking zone and gets a parking ticket. Though that's happened to be A and B. So we say from the problem, the first sentence gives us probability of A and B equals 0.06. And then it states that the probability that Sam cannot find a legal parking space and has to park in the no parking zone is 0.2. So no parking zone is 0.2. So that means probability of A equals 0.2 because Sam has to park in no parking zone, 20% chance. Then let's look at the question. The question is probability that he gets a parking ticket, that's probability of B. But given that Sam has to park in a no parking zone, so given event A. So the question is to calculate this conditional probability of B given A. So now let's look at the formula. That's probability of A and B divided by probability of A. So whatever given, you're going to use that as the denominator. Then we know probability of A and B is 0.06 and probability of A is 0.2. And we got 0.3, 30% chance. That is the result for this example. So section 4.3. So for this one, let's stop here, and then section 4.4, we're going to record another video.